Hi class, hope you guys are doing well. Welcome to a lecture on independent samples t-test. In this lecture, as you now know, we will cover independent samples t-test. First, I'll introduce some background information about this t-test. Then we'll take a look at the demo, and then it'll be your turn to run the t-test. So let's get started. So let's first talk about what a t-test is. So t-tests allow you to test hypotheses about mean scores. And so if you see questions about either one mean or two means, then you might want to start thinking about using a t-test. And there are technically three types of t-tests. The first one we're not going to go over in this course. It's a one-sample t-test, and you might have already seen that in a prior statistics course. The one-sample t-test compares the sample mean to see if it's the same as a non-population mean. Today we're going to talk about between subjects or independent samples t-test, and what that does is it compares mean scores of two different groups to see if those means are different or the same. And then next time we're going to talk about within subjects or dependent samples or paired samples t-test, all the same thing. And what that does is it compares two scores from a single or related group to see if those two scores are the same. Technically, you're testing to see if the average difference between those two scores is 0 or not. And we'll talk more about that next time. And so these are the three different types. Now let's talk about the kinds of variables that you need for t-tests. First, you need one continuous dV. And that is a variable for which you're comparing means. And you need one categorical IV with two levels. And levels is just a fancy way of saying categories. That's a technical term. And so when I say one categorical IV with two levels, then that means two categories. Now technically, you can have more than two levels in that IV, but you'd choose two to compare means for. And so in the example today, we're going to have the IV define your groups for independent samples. And so group 1 and group 2 for which you're comparing the means on your DV. Next time, we'll talk about the IV giving you two measurement occasions, and you'll see more what I mean when we get there, and that is for the dependent samples t-test. So the IV defines two categories for which you're comparing the DV. Now looking specifically at the independent samples t-test, this means that you're comparing the mean for group 1, defined by your IV, and seeing if that is the same thing as the mean for group 2, again, also defined by the IV. And so group 1 and group 2 would be two levels of your IV, and you're comparing the mean of the DV across those two groups. So let's say that you wanted to compare two different groups of people in your sample on a particular variable. And so you wanted to compare the average scores, for example, children versus adults, psychology versus sociology students, or Disney fans versus non-fans, and you wanted to hypothesize whether or not there's a difference between the two population means for that variable. So one continuous DV comparing the means for these two different groups. The alternate hypothesis would say that there is a significant difference, whereas a null hypothesis would say that there's no difference in the population means, so those two different groups in the population. And you can write the notation in two different ways. So mu is the population mean for group 1 versus group 2. So the difference is 0 for the null hypothesis, or those two means are equal. The alternate hypothesis would say that there's a significant difference between the two. And so mean for one group is different from the mean for the other group. So here's the formula for the independent samples t-test. And again, this is meant for you to get an intuition behind what is happening and not for you to commit the equations to memory or anything like that. But what the independent samples t-test does is that it compares two sample means and calculate a t-statistic by taking the sample mean difference, so the mean of the first group minus the mean of the second group. So that's the sample mean difference, minus the hypothesized population mean difference, which really is 0, divided by the estimated standard error. And the equation looks like this, translated to statistical notation. And this t-statistic will come with the degrees of freedom that is essentially the sum of the degrees of freedom for both groups, which really totals up to the total sample size minus 2. So if you break this down, then you get the sample mean difference here, the hypothesized population mean difference is 0, and then the estimated standard error in the denominator, which is an index of how much the mean difference in the sample differs from the mean difference in the population, and so really how much error you have in estimation. So that's how you get the t-statistic. And the t-statistic is distributed in a way that's very similar to normal distribution, so with a bell curve, but it's adjusted by the degrees of freedom. And it really accounts for the fact that you have to estimate the population variability using sample data. And so the more data you have, the closer to normal distribution it gets, but less data you have, so essentially fewer cases or lower degrees of freedom you have, then the flatter the curve gets. So you get this t-statistic, and then you have to test your hypotheses using that value. So let's take a look under the hood and see how you run the t-test. So you and RStudio work together to do the following. First of all, you compute the test statistic. In this case, it's the t-statistic. And then you compare the test statistic against its distribution to determine the p-value. And then you evaluate your hypothesis and determine whether or not you reject or retain your null hypothesis. Now, luckily for you and for me, RStudio does number 1 and 2, and so your time to shine is number 3. And so thinking about it under the hood, what's happening is that there's a distribution for the t-value, and there are critical regions in the tails. If this is a two-tailed test, then the critical regions are on both sides. If it's one-tailed, then it's only on one side. And you're asking whether your t-statistic that you calculated for your sample is extreme enough, farther off into the tails, enough for you to reject the null hypothesis. And so in the background, RStudio is looking up things using a probability table kind of like this. Remember the days in maybe elementary statistics when you might have used a table like this? Well, congratulations, you've moved up in the world. So RStudio will do that work for you. Huzzah! And then you get that p-value, and what is it? So the p-value tells you the probability of obtaining a test statistic value that is that extreme, so as extreme as what you got, if null hypothesis happened to be actually true. And so if you think about the way the t-statistic is calculated, if null hypothesis was true, so that means that the two groups had equivalent means, so the means are the same, then the t-value should be close to 0 because t-statistic is based on the difference between those two means. And so the closer the two means are, the closer to 0 the t-statistic would be. And so if the null hypothesis happened to be true, then you would expect that the t-value would stay close to 0. And so the greater or more extreme t-value, the farther away you get from the middle of your distribution and the closer you get to the critical regions in the tails. And so third step, if the p-value falls into that critical region that's determined by your alpha, that means that p-value is less than alpha, then you reject the null. And so that is what's happening under the hood for the t-test. Alright, and one more background piece of information to cover together, which is the assumption of homogeneity of variance. And so you might remember me mentioning this when we covered the parametric assumptions, but you want to check to see if the variance for your dependent variable looks the same for both of the groups that you're comparing, kind of like this, as opposed to the alternate hypothesis where the variances are not equal, in which case you don't meet this assumption of homogeneity of variance and you will need to make some adjustments. And so this is desirable, this is not. Now, we'll talk a little bit more about how to test for this in RStudio when we get to the demo, but something to remember is that you use the Levene's test in order to test the hypotheses that I just showed you. And you can run that in RStudio by using the var.test function, where the y represents the dependent variable, which should be continuous, and then x represents the independent variable, which should be the categorical variable that gives you those two groups. And what you would do is to save this var.test into an object and then print that object. So that was the background information on independent samples t-test. In the next segment of the lecture, we'll go over how to run it in RStudio and interpret it. See you shortly.